Okay, we're recording this seminar today. I'm Ben Domenico from the Unidata Program Center here at UCAR, and it's a joint seminar sponsored by Unidata and the UCAR GIS program. So we're hoping all the system is set up. It looks like it is in the back for the recording. We're lucky to have with us today Stefano Nativi and Enrico Boldrini, both from the Italian National Research Center, the Florence Division, and they are members. Stefano leads a group called the Earth and Space Sciences Informatics Group, and Enrico's part of that group. And we've worked with them over, I guess it's decades now, beginning a second decade. So we're pleased to have them visiting us. They're on their way, stopping between the ESIP Federation meeting in Copper Mountain and leaving tomorrow for the Esri meetings in San Diego. So we're pleased to have them here in Boulder for a brief visit. Stefano's topic is on the board or on the sheet behind us, the Geodata Access Broker, making the GEOSS infrastructure operational. So finally, at this point, moving into a stage where GEOSS can actually be used and facing the issues that you face when you get to that point. So without further ado, I'll turn it over to Stefano.
Thank you. Thank you, Ben. Thank you very much. Yes, this presentation will try to explain you what the GeoDAB is, because I'm sure that you are not very well acquainted with the GeoDAB concept. GeoDAB is one of the components, as I will explain, of the GCI. The GCI is the cyber infrastructure, the common cyber infrastructure of GEOSS, and I will try to also explain what GEOSS is. And this activity, as well as many others in the GEOSS framework, have been funded by the European Union Commission by several projects, and I just mention the three most important projects that funded us. Okay, so this is what I'm going to tell today. I will cover the GCI 2.0. This is what I use to call the new GCI framework. And of course, there are new challenges, so we try to explain and to cover which are these new challenges, and in particular what the DAB, this brokering framework that we have been developed and we are extending, which is going to be the role of DAB as far as these new challenges. Okay, so maybe if you don't know much about GEOSS, GEOSS is a program managed by GEO. GEO stands for Group on Earth Observation, and GEO was launched in order to answer to many requests coming from G8 and others World Summit. It is a voluntary-based governmental effort. Now we have something like 90 different governments plus the European Commission and 77 international organizations. And the main, task of GEO is to develop, maintain, and operate GEOSS. GEOSS stands for Global Earth Observation System of Systems, and as you can see, the target, the audience, the user target for GEOSS is composed by many different areas. Here we have 9 societal benefit areas. They are called societal benefit areas, and they go from disaster to health, energy, agriculture, weather, water, biodiversity, ecosystem. So it is a real multidisciplinary effort covering many different areas, and this is one of the important topics as far as GEOSS. The other two are that it is global, so it's not just Europe, it's not just the US, Asia, or China. It is really global, and it is a system of systems. System of systems means that we have to build on existing systems, and this is the only possible way in order to build such a global, cross-disciplinary, multidisciplinary cyber infrastructure and maintain them. Okay, so this is a very oversimplified schema of what the GEOSS architecture is. So we have two main actors, two main, members of GEOSS here. Of GEOSS here. One is the GEOSS user. So GEOSS user wants to access what is called the GEOSS common infrastructure, the GCI, in order to, discover and access data, knowledge, information. The other actor is the resource provider, who is interested in registering its own data or its own component system. Okay, here are the component systems, tools, and data managed and operated by the different members of GEOSS. They are our resource providers. And of course, the GCI must interconnect these systems, building what is called a system of systems. So this is why it is absolutely important to build on existing systems, existing components and services. Okay, the GCI, the GEOSS Common Infrastructure, is in charge of providing a set of services. Let's start with the discovery strand here. Through the GCI, users must be able to discover resources, not only data but also services and tools, by submitting queries by space, keywords, time period, the resource type, etc. This is usual, but we also are targeting other advanced constraints such as why. So if you are interested in discovering resources to address one particular question, you should be able, users, GEOSS users, should be able to navigate and discover resources which are useful to address their specific questions. Then semantic searches, so even if you are not expert in one particular area, and GEOSS is covering at least 9 main different domains, so if you are not expert in ecosystems, let's say, you can submit queries by generic keywords, and those keywords are mapped and they are specialized according to the ecosystem domain, for instance. And then multi-step, because when you access Earth observation data sets, generally, such as satellite data, they are coming as time series and or space series. So a huge amount of data. In several cases, it is useful not just to submit one query, but 2 queries. The first one is to discover the series, and the second one is then to select inside one serial which is your useful snapshot. Okay, so this is another interesting capability as far as discoverability. Then, of course, when you discover something, you have to evaluate what you have discovered in order to understand which data or which resource is really matching your needs. And so here it is important for the GCI to provide the following functionalities. Metadata harmonization, so you can combine different, different resource information in order to allow users to compare those data sets. Quality check, so you may understand better which is the quality level. And the legal constraints, a very important effort of GEOSS is to push open and free data. This is called, in GEOSS terminology, this is called GEOSS data core. So GEOSS is GEO, in this case, is really pushing its members to publish data set as open and free data. And preview, when you have discovered some data, you would like to have a preview in order to understand where those data are and if they are at the right, spatial resolution, etc. Any user feedbacks. You may be interested in understand better which are the most common usage for those particular data sets. So these are some of the capabilities that the GCI should implement in order to support user needs. Then access and use. When you have evaluated the discovered data set, you select one, two, or more of the data set, and of course you want to download the data. And the second important capability is that in doing that, you want to get this data according to a common framework. So let's say a common coordinate reference system, a common spatial and temporal resolution, a common format. So the GCI should be able to provide these simple processing and transformation activities. And now we are also considering most advanced processing in order to extract useful information, not just transform data. So these are the main capabilities and functionalities that the GCI is requested to implement. This is the present GEOSS, not just the GCI. Yeah? GCI is the green bubble here, but this is the entire GEOSS schema. So this is the current architecture of GEOSS. And as you can see, inside the GCI, we have several components. This is the present situation. I will try to cover what the GCI 2.0 should become. So maybe we can say more about all the different components. What is important now to say is that there are some components. It's not just a unique software, but there are many components, software components here. And what is noticeable for us is that if you want to register your own service or system, you have to access a component which is called CSR, Component Service Registry, and register your resource. And the clearinghouse catalog, which is a clearinghouse catalog, so a catalog of catalogs, basically, is accessing the content of the CSR and harvest all these resources, all this catalog content. Then the DAB, the Discovery and Access Broker, is brokering the clearinghouse catalog as well as many other systems directly. Okay, so here we have this very strange, situation, mixed situation, and this is why in the GCI 2.0 we decided to clean the architecture and to make it simpler and hopefully better. Okay, so this is another view of the GCI and the GEOSS as far as the discoverability and access of data. So here we have a GEOSS portal. You can access directly the GEOSS portal, or you may access it through the GEO homepage, and users submit requests to the GEOSS portal, and the GEOSS portal forwards each of them to the GeoDAB, the brokering framework. The brokering framework is brokering a set of existing systems, and those systems can be very simple, such as a database, or very complex system, such as an entire federation. Here we have, for instance, GEOSS. GEOSS is a federated system. Through GEOSS, you may discover and hopefully access data set, mainly time series, provided by JAXA, NASA, US, GS, ESA, NOAA, etc. Okay, and the same is for the WIS, the WMO information system. Here, I mean, you have a federation of different nodes of WMO. And I mean, so this is how the GCI works as far as the system of system building. And as I said, if you want to register a new system and or component, you have to enter, you have to submit a new entry to the GEO register. The CSR and the clearinghouse catalog is directly connected to the CSR, and the DAB brokers to the clearinghouse catalog. On the right side here, you have other systems coming from the private sector. All these systems on the left side are coming from the public sector. And recently, GEO decided to open to the private sector. So we have started testing interoperability, so mainly, apply the same brokering approach also to private cyber infrastructures, such as Google, Esri, or CompuSalt, and etc. So we have started, and I will cover this because it is going to be one of the new challenges for the GCI 2.0. Okay, let's talk about the current numbers, assets. This is the situation in May or June 2014. Here, we have more than 30 brokered systems. Actually, there are 33 or 34, and they publish something like 13 millions of complex data set. Complex data set means that they are mainly time series and or space series. And so if we go to the granularity level, so the single transferable file, we get numbers such as 70 millions granules, and the good news is that more than 50 are GEOSS data core, so they are open and free data. Okay. Well, as I said, this is maybe a bit old. If you want to check the last report, you can go here. You can follow this URL. And here we publish every month the updated numbers. So this is, for example, the 27th of June, and the total number is 74 millions, and 54 millions are open and free. And we will publish one report each month. So let's talk about the future. What can be the GCI 2.0? And of course, we will have the GEO web portal. So the GEOSS user still has to go to the GEOSS web portal, submit one query, one general request, and the GEOSS. The GEOSS resource providers can still register their system and or component through a sort of registry, a very simplified registry component. But this time, the GeoDAB will be connected directly to this registry. So we don't have anymore the clearinghouse catalog, and the CSR will be definitely simplified, so that the GeoDAB is directly connected to this registry, and reading the entries of the registry. The GeoDAB is brokering directly the data set and the services and tools provided by the GEOSS members. Okay, and clearly, GeoDAB will also continue accessing the very complicated and complex federation systems, such as this QUIC, the GEOSS QUIC, or the ESA, FIDEO, etc., many others. And so, I mean, this will stay there, and the GeoDAB so has to implement two different kinds of approaches. One is direct access, and mainly trying to harvest directly the content of the systems. The other one is to distribute a query to complicated and complex systems, because they don't want to be harvested directly. So both these approaches are still there, and I think that they will be for many years, because we have to accept the needs and the constraints coming from the existing systems. And of course, there are some GCI components which are useful in order to augment the functionalities that GEOSS is providing to its users, such as a set of registries in order to have a list of the standards and or interoperability specification used by the GEOSS members, or the user needs, the user requirements, the best practices. And on the other hand, here we have monitoring services, so that GEOSS can understand how all these components, including also the brokerage systems, are working. Because here you must trust on many different software components. So you need to understand what is working and what is not working correctly. And then you have to take decisions in order to adjust the situation. So exactly, okay, this is the same schema that I showed before. And what will be exactly is that the clearinghouse catalog will disappear. The GeoDAB will do what the clearinghouse catalog is doing now, and the geo registry will be attached directly to the GeoDAB. Very simple. Clearly, we have to face several challenges as far as the GeoDAB. And this presentation is mainly about the GeoDAB, so I'm focusing on the brokering framework challenges. And this framework has to face several challenges, mainly scalability, And so the GeoDAB is running in the cloud, on the cloud here. And this is, for instance, the present configuration of the GeoDAB. And as you can see, there are several nodes, several virtual machines have been used and will be, used in order to manage all the queries and requests coming from the GEOSS users. So, for instance, for the last ministerial meeting, we had we used 15 nodes, machines for the discoverability, so for the discovery broker, because we have a different broker for each main functionality. So we had 15 virtual nodes for the discovery broker, 6 for the access broker. We had 3 nodes in order to perform a quality check of the broker system. So we know whether those systems are up, if the network connection is sufficiently good or not. These are all useful numbers, information, in order to allow the broker to, rank the matching results. Because when we match, when we discover, results, we need to provide those results back to users according to a certain order. And this order is coming by applying a specific matrix. And one parameter of this metric is the quality. So how good is the connection? How good is the quality of service provided by the geo providers? Okay, so this is why we need to run this particular service. Of course, we need to use cloud capabilities. Such as the elastic load balancing, the tiling, the NoSQL tiling approach, etc. My next topic is how are we going to simplify the current registration process? Because currently the registration process is a bit cumbersome, and we had several comments about that. So as I said, we are planning to make it easier. And in particular, this is what we are discussing. So we have three different actors. The first one is a new data provider. So let's say that you want to register a new component. So you go to the GeoWeb site, where there is a very simple web form, very simple, and this web form is composed of few elements, few fields, and you need to fill, of course, these fields. This is the list of possible fields, and as you can see, they are few, and in particular, most of them are optional. So what you are basically required to provide is information about who is in charge of that component, the name of the organization, a technical point of contact. So not a political point of contact, but a technical point of contact. The service level agreement, that means that you can say, I commit to maintain this service running for 90% of the time or for the 50%, etc. Estimated number of the collection, let's say time series, is optional. Estimated number of data cores, or of open and free data, is optional. Estimated number of granules, so the real and effective downloadable files, is optional as well. So as you can see, the real important information, mandatory information, is limited and is at a very high level, no technical details. Of course, if the new data provider has some question, she can contact Geo and clarify what these elements are. Then the GeoSec takes the lead here, so check the content of this web form. We call them yellow page entry. And what is particularly important for both sides, for the data provider and Geo, is that the GeoSec, jointly with the data provider, may release a press news. So you can say this new agency joined Geo and is publishing this particular valuable data set on GEOSS. And the last task for GeoSec is to virtually introduce the provider technical point of contact to the GeoDAB and the GCI team. That's another important point, because now that we have accomplished a sort of political registration, we need to start with a technical one. And what is our vision is that GeoDAB can go and directly access the service and download and understand all the metadata needed in order to broker those services of that service. Clearly, in some cases, this will not be possible, and so it's up to the GCI team, to the DAB team, to contact the technical person of the data provider and work together in order to finalize this brokering phase. So this is a political registration phase, and this is the technological one. So that's what we are discussing now, because the current registration phase is a mix. And what is happening now is that the data provider must ingest a lot of very different information. And this is often difficult for especially non-technical people. The other point is that now GEOSS has no accounting, so you can just enter it. You don't have to register, okay? This is positive, clearly, because you don't have to go through this particular phase, but on the other hand, Geo and GEOSS don't know anything about their users. And so Geo and GEOSS cannot provide a sort of simplified and advanced experience according to the different user types. So what we are going to implement for the next plenary is a login service. A very simple login service. Clearly, it's open, so everybody can do that. And what we want to do is to support existing accounts with Facebook, Google+, and LinkedIn. And no, did I skip it? No, okay. Then user feedback. As I said, as soon as we are able to understand and track our users, then we can set up social services. So we can say, okay, please provide us with your feedback, because now we can implement this particular kind of services. And what we will do is to use a catalog, which is called a feedback catalog. A prototype was experimented and developed in the GeoViqua project, one of the EC, European Commission funded project. And so this feedback catalog can be accessed by users directly through Geo or also outside Geo, and provide feedbacks on GEOSS data. So the real challenge here is to maintain, align the GEOSS data ID with the feedback ID. So that's the real challenge. Otherwise, it is trivial, but this is the tricky point. Then private sector. As I said, GEOSS decided to open the floor to the private sector, to the contributions coming from the private sector. And this is another possible diagram reflecting the GCI and the GEOSS system. So here we have a GCI platform. Here we have all the different GEOSS societal benefit areas with their applications. Okay? And here we have the systems provided by the GEOSS data providers and brokered by the DAB and the GCI. So what mainly happens now is that these systems provide services at the discoverability and accessibility level. So they publish, in very simple terms, they publish services such as catalog or such as access services, map service, coverage service, feature, or whatever, opened up, etc. In some cases, we have also some processing, but generally it is a simple analytics, service. when we tried to approach the private sector, we discovered that actually these private sector cyber infrastructures are providing or may provide us not just with discoverability and accessibility and maybe some processing, but also with complex process, complex analytics, as well as applications. They have, they publish, applications. So the challenge here is how can we broker or interconnect those private sector cyber infrastructure, establish what is called interoperability agreements in order to share data, but not only data, also to share applications and in particular to share analytics. So this is the challenge now for us. It is not only a technical challenge, of course, it is also a political challenge, but as far as the DAB, we are interested in the technological challenge. And another challenge is that according to, and in keeping with the GEOSS approach, the GCI, and in particular the DAB, must be able not just to broker one private sector cyber infrastructure, but several of them. We have to, we have to be the broker, not just an end-to-end interoperability artifact. So this is another, another challenge because they are using different, standards or different APIs or different tools. The other challenge for GCI 2.0, and this is going to be a very important point, is that, okay, we are able to provide discoverability and hopefully access to millions of different data sets, okay? The problem is that we don't know much about those data, okay? So we need, if we want to deliver not just data, even if they are big, but something more useful to our users, such as information and hopefully, in a medium-term knowledge, we need to know better what is contained in our GCI or in our, GEOSS. We need to be able to distinguish what is a raw observation and what is a variable and, better an essential variable, so a very useful variable, what is an indicators, what is sustainability indexes. All these are present here, mainly observables, mainly observations, but there are also variables, essential variables, and indexes. But presently we don't know. We are not able to, distinguish what is an observation, what is an index. Okay, so we need to capture this important information. We need to understand how we can raise our knowledge about the brokered and the accessible data. And these are, essential. This knowledge is, essential if we want to provide a good answers to our users' questions, because users, GEOSS users, they want to, answer to important questions such as how will climate change affect infection rate of dengue disease in one particular area. So we must be able to provide data saying this is the index useful for your question, or these are the essential variables, and then you have to produce indexes, etc., etc. So this is a clear challenge for GEOSS. So let's try to, summarize what I have said so far. We have the GeoDAB, as I said, this presentation is focusing on GeoDAB, so I always start from this component. So we have the GeoDAB. Presently, the GEOSS portal is using the GeoDAB to satisfy users' request, The other represent client is the GeoNetcaster. I haven't covered these, but the GeoNetcaster is a satellite-based system in order to reach those areas which are not covered by a large, capable internet connection. So we use this broadcast system. And the GeoNetcaster is able to access GeoDAB, take all the metadata content of the GeoDAB and broadcast it. So these are the two main clients as far as the GeoDAB, and the GeoDAB in turn brokers several existing system and data cyber infrastructures, mainly public. What the GCI 2.0 will do is to broker also private systems and cyber infrastructures. Hopefully, we will do also the same as far as crowdsourcing data systems, and we will simplify the current registration process by publishing a light yellow page service, and the GeoDAB will read directly the entries of these pages, and we will also access and use a GEOSS feedback catalog in order to augment the metadata for each data with feedbacks coming from users. And finally, I haven't covered these, but we are also thinking to develop and maintain a catalog for the black data, black or gray data, what is called long tail data. So, let's say scientists who are not able to publish their data, they can go to GEOSS and say, can you publish my data? This is what I see as the GCI 2.0. And okay, I just tried to summarize a few sentences here. So GCI 2.0 should go from a catalog of catalogs to a multidisciplinary brokering platform. From discoverability, the accent should be on accessibility and processing, from data to information and knowledge, from only authoritative data to also crowdsourcing, and from expert users to different kinds of users, so to put in place what is called user profiling. And my last two slides are about big data, because one of the questions is, GEOSS is not dealing with big data. Well, I'm trying to explain that this is not true, because when we talk about big data, we think of big data challenges, and these are the challenges, the famous V's. So let's talk about volume. Well, GEOSS has to manage millions of discoverable small and medium products, and in particular has to manage long Earth observation time series. So I think that volume challenges are there. Of course, variety. GEOSS is covering 9 broad domains, and datasets are coming, dataset and or products are coming in different formats through diverse protocols and services with completely different models, etc. And of course, there are, as I try to cover, very diverse granularity levels, observations, variables, index, indicators, etc. And coming from heterogeneous areas. So variety definitely is a challenge for GEOSS, and GEOSS has done many things in order to address those challenges, as I try to cover with my previous slides. And then one of the other these is veracity. So here in this case, GEOSS has developed a way to submit queries by quality constraints, by including some constraints about quality. We will also, I mean, now we are ranking our results also according to the fit for purpose and whether these data sets are or not essential variables. And we will add user feedbacks. The other challenge is velocity. And in this case, we put in place, we are using, I mean, we means Geo, is using the GeoNetcast system in order to reach those areas which are not covered by a good internet connection. And the other point here is we need to work more on, providing not just data, not just thousands of matching data sets, but to provide the right level of data. So they could be observables, they could be essential variables, they could be indexes. That's the real point in order also to address velocity change challenges. These are conclusions, but I think that I covered all these points with my previous slides. And of course, I mean, we are very much in the brokering framework development. So we see the brokering framework as one important component in order to satisfy and address all these needs and challenges. And I finish. Thank you for your attention.
Thank you, Stefano. You covered a wide range of topics there, big data just in the talk. So this is being recorded, as I say, and unfortunately a lot of people are out of town now, but we hope to record any of the questions as well. So I'll ask you to use the mic if you do have any questions. Any?
Can you say anything about the technical implementation of the brokering framework and what it's? Is it built on an existing system, or is that something that you're developing from scratch?
Thank you. Yeah, sure. I mean, I haven't covered these because I didn't have much time because, well, yes, the so-called GeoDAB is based on a set of software components developed by the CNR, and which is called the GI suite. So there are one broker for each main capabilities or functionality. So there is the GICAT for the discoverability, GIAX for the accessibility, GISAM for the semantic augmentation, etc., etc. So yes, it is based on this software. And what we have done basically for the GeoDAB is to start from this framework, software framework, and decide how to use the brokers. Because the brokers are software components, but then you have to, ensemble them. You have to, decide several things, such as which is the right metrics for you. Which are the systems that you want to broker and according to which approach. So let's say you want to distribute the query, you want to harvest, and you have to devise a specific plan for each brokerage system. And then we also, for the GeoDAB, we also develop specific APIs in order to allow the GEOSS portal, but also other clients, because I didn't mention. But part of the GEOSS architecture are also the community portals. We don't have many of them, but there is a very strong push in order to implement community portals. So the GEOSS portal is the general portal where you can enter into GEOSS, understand how many data sets are there, etc. But if you are interested in one particular area, you may decide to use your client and or develop a new client, a new portal, and access the GeoDAB. So we develop APIs, high-level APIs, in order to use the brokering framework. And the other important development done for the GeoDAB is to is to install and configure this GI suite in the cloud, sorry, because clearly, this very much depends on your needs. In this case, as I tried to explain, GEOSS has pretty demanding needs, so we needed to use a very capable cloud, flexible, scalable cloud in a short time. For instance, for the plenary meeting, we were asked just to add new instances because we knew that more people, were trying to access the GCI and GEOSS. So we had a specific, deployment plan and configuration plan for GEOSS and the GCI. So this is the sort of things that we have done for the GeoDAB by using the GI suite. I don't know if I answered that. I'm sorry. Yeah, please. No, but I think that I cover the subject.
Yeah. Any other questions? I have one comment and a question, or kind of a follow-up on something we were talking about earlier, and I think it relates to the idea you were talking about of the desire not to provide just raw data, but data that helps for higher levels of understanding and knowledge. And I think the NCAR GIS project, has done something along those lines in moving from the raw data of climate prediction ensembles to process products like anomalies and such. And so their data sets that I assume we could register with GEOSS would have already taken a step. Is there something that should be done to indicate that, or so that the end user would know that they were looking at something that was beyond the raw data? Or
no, indeed. That's our next challenge, because clearly when you register your data, as I have said, we try to make your life easy. So we are not asking you for tens of different metadata, entries, elements. We are just asking few important information, but we don't want to overload, you. And this is good. On the other hand, clearly, we have to infer lots of things. Okay. In some cases, this is easy, because you are publishing well-documented data sets and or services. For instance, if you use a standard catalog service, generally you have to provide a lot of information, and that's one point. But on the other side, you don't provide generally this kind of information about at what level of of the, let's say, granularity and or what level of content your data set is. So we need to work on two different lines. One is to push data providers to include this information, to say this is an essential variable, so this is an indicator, okay? By tagging it or by providing this piece of information in some place. On the other hand, at the GEOSS level, we are working in order to understand which are the well-accepted, let's say, essential variables and or indexes, and to pre-process the content of the GCI or the GEOSS in order to tag ourselves data set. So if you are publishing one data set, dealing with one particular variable, we can check whether that variable is essential, is by the scientific community, recognized as essential variable for one particular domain. Let's say it is one of the climate change essential variable for the soil, So we know, we can go, we match this information, and we can tag it. So we know when GEOSS users ask us about, climate change and soil variables, we can dispatch first that data set because it is more usable, let's say usable, than others. So this is the kind of thing. So two parallel actions. One is to motivate data providers to tag or to provide more information about the content of their data. And the other one is to do this task ourselves, so to try to understand what people are publishing, what scientists are publishing.
One other question that occurred to me early on is you mentioned actually doing some processing in the GEOSS context, and I'm wondering if at this point or sometime in the future there will be the opportunity to contribute or register processing components as well. The one I'm thinking about is you mentioned, wanting to have the data sets all delivered on the same spatial resolution. Well, in NCAR now, in the community here, that's a rather significant scientific challenge in the sense that downscaling and upscaling is actually part of the science that's done. And so I picture in the future at some point somebody being able to contribute a downscaling algorithm or code or whatever.
Sure.
And I'm wondering how far along you are or where you see that coming in the future.
Well, actually, you can do it now. If you want to publish, to register, let's say, web processing service, you can do it. The real point is that the present system is not able to use it. Okay, so what is missing now? It is once more to understand what is registered and how to use it. This is the knowledge that the system doesn't have now. But we are working in order to include this knowledge so that we know. And as far as I mentioned, the access and the brokering, performing these access and transformation tasks. Well, definitely this access broker is now capable of using external services. So of using, let's say, registered processing services in order to transform and map data set. What is missing now is the knowledge that those services are registered, are there, and they are accessible and usable.
So a user now might go and discover data sets they're interested in and want a more sophisticated approach to downscaling than is available as part of GEOSS now, and might in fact find that algorithm, but the user would have to access the data and access the access the web processing service. Exactly. And make the connection themselves, whereas in the future you would like to integrate that downscaling into the system.
The access level.
Yeah, that makes sense. That's a big challenge.
Yeah.
Right.
Indeed.
Any other questions? All right,
thank you.
Grazie,
Prego.
mille grazie,
Prego.
Stefano. We want to thank Stefano and Enrico for coming on.
Sure, of course.
So.